right, so the lesson is starting. We're recording. This is Unit 5, Day 2. And we're going to talk about isosceles and equilateral triangles. And then we're going to start talking about some congruence figures in just a little bit and get you a little intro to that. So let's first start by talking about the parts to an isosceles triangle. We learned in the previous lesson what is an isosceles triangle. Two sides are congruent, okay? So those two sides that are congruent are called the legs, okay? The two sides of an isosceles triangle that are congruent are called the legs. And you see that? What does that little red tick mark mean? They're congruent. It don't have to be red, but the tick marks means they're equal measures. Now, the legs meet together at an angle that we call the vertex angle. Okay, so where the two legs meet, the two congruent sides meet together at the vertex angle. The other two angles that are kind of, sometimes they're at the bottom, it just depends on how the triangle is turned, are called the base angles. Okay, so they meet at the vertex angle. The other two angles are called the base angles. So on the back of your theorem sheet, we have something called the base angles theorem. It's like the third one from the bottom or something like that. The base angles theorem, it's like right here. I think it says 4.7 on the handout. If two sides of a triangle are congruent, then the angles opposite them are congruent. So if two sides of a triangle are congruent, we know it's what kind of triangle? Isosceles. So isosceles means that the two sides are congruent, but also the base angles theorem is telling us that also the base angles are congruent. So if we have an isosceles triangle, we know a lot of things. We know that two sides are congruent, and we know that two angles are congruent. Okay? So below that, we have the converse of a base angles theorem. Now, what does the converse theorem do? It reverses the hypothesis and the conclusion. Y'all with me? All right. So a converse theorem reverses the order in which you say the hypothesis and conclusion. So the base angles theorem said if two sides of a triangle are congruent, then the opposite angles are congruent. The converse says if two angles of a triangle are congruent, then the sides opposite are the congruent. So this one is saying if the base angles are congruent, then the sides are congruent. Okay, so that's the converse. So the original base angles theorem said if two sides are congruent, then the base angles are congruent. This one says if the base angles are congruent, then the sides are congruent. Okay? So that's important information. All right, here's an example. In triangle DEF, side DE is congruent to side DF. Now, y'all don't have to write this down, but I need y'all paying attention. Name two congruent angles. So they gave me two sides that are congruent to each other, and they're marked. So what angles are congruent? Well, how many letters do you need to name an angle? No. No. Three. Angle EFD is congruent to what angle? FED. Very good. So if those two sides are congruent, then D is the vertex angle. So that means these two angles are congruent. Does that make sense? Because D is the vertex angle because that's where the two congruent sides meet. So the base angles are congruent. Questions about that? So if I know their measures or I know one measure, I can set them equal to each other. If it's a problem, if this is x plus 15 and this is 3x minus 5, I can set those equal to each other and solve for x. Right? All right. Look at this picture. So they're going to tell us something is congruent, and then we're going to use either the base angles theorem or the base angles converse theorem to tell something else is congruent. Okay? So this one says, I'm going to mark my picture because that's going to make more sense. Okay? So I've got two triangles that are kind of scooted up against each other. They share the side HK. And they tell me that line GH, which is right here, Yep, it's congruent to which one? GK. Now, am I using this little triangle over here? No, I don't need it right now. I'm just looking at the left side triangle. So what angles are congruent then? GKH. Right, these two would be the base angles because this is the vertex angle. Does that make sense? Does that make sense to everybody? So angle GHK is congruent to angle GKH. So if those two angles are, or those two sides are congruent, then these two angles are congruent. That makes sense? All right, I'm going to do the next one in blue, so maybe it won't get too confusing with my marking. All right, this one tells me that angle JHK, which is this angle up top, is congruent to angle KJH. Well, KJH, J is the vertex, so it's that angle, right? So if those two angles are congruent, which two sides are congruent? Very good, HK and JK. Because those would be base angles, so that means those two sides are congruent. So HK, segment HK is congruent to segment JK or KJ, right? Any questions about that? I've lost my little clip and I can't find it. I'll have to dig for it during planning time. All right, so if base angles are congruent, then you have two congruent sides. If two sides are congruent, then base angles are congruent. Okay, can we scroll? All right, theorem sheet. Very bottom of the back. So we've got the base angle theorem, we got the converse of the base angle theorem. Now we're going to have a corollary to the original base angle theorem, and then we're going to have a corollary to the converse of the base angle theorem. So we're still basing everything off the base angle theorem. Now remember, we kind of talked about previously that a corollary is a theorem that you get based from a previous theorem. Okay, so like we had, I think it was yesterday, a corollary to the triangle sum theorem is when you have a right triangle, the two acute angles in the right triangle were complementary, right? That was a corollary to the triangle sum theorem because that was based off of all angles in a triangle had to be 180. Okay, so this one is going to be based off of the base angle theorem. This one is based off of the converse to the base angle theorem. So the corollary to the base angle theorem says if a triangle is equilateral, then it is equiangular. Now, what does equilateral mean? All sides are congruent. So if all sides are congruent, then all angles are congruent. That's what that one's saying. Now, the corollary to the converse of the base angle theorem says if it is equiangular, then it is what? Equilateral. So you see how those are kind of converses of each other? Okay? So if we have equilateral, then it's equiangular. If it's equiangular, then it's equilateral. So if all the sides are the same, then all the angles are the same. Specifically, what are the angles of an equiangular triangle? They're all exactly how many? 60 degrees, right? Because it's 180 divided by 3 if they're all the same. All right. Geniuses. Find the third angle theorem. Third angle theorem. Where's it at? Okay, it's like 2/3 of the way down on the front side. Front side. There you go. All right, how about that one? If two angles of one triangle congruent to two angles in another triangle, then the third angles are also congruent. So if you know two angles are congruent to two other angles in another triangle, then obviously the last ones would have to be congruent to each other because they have to equal 180. All right. So now we're going to see some examples based off of those corollaries and theorems. Find the measure of angle P, angle Q, and angle R. How do you know? Right? The little tick mark says this is an equilateral triangle, right? All sides are congruent. And we just learned if it's equilateral, then it's also Equiangular, which means they're all congruent. So you just write down measure of angle P.
Is this your practice one?
No,
Easy.
it is, but it's the basis of it. Y'all gonna have fun on practice, but you got to mind. It's just a one pager. So yeah, if we know it's equilateral, then we know all the angles are equiangular, so we know they're all going to be 60 degrees. All right, this is going to be more like the practice. Ish. All right, draw this picture. Yeah, you'll want an example of this because you might see some practice like this. Draw this picture. What kind of triangle is this figure? It's isosceles. How do you know it's isosceles? Two sides are congruent, right? And we want to find the measure of angle X and angle Z. Now, what are X and Z? What kind of angles are those?
Oh, that's Z.
Yeah, that's a Z. Sorry. All right, what kind of angles are they? They're base angles. So what is this 50-degree angle up here? The vertex angle. So what do we know about base angles? If it's isosceles triangle, then the base angles are congruent. I don't know what they are, but I know they're congruent. Does anybody have a thought process that we can maybe use? Okay, start. There you go. So we know all three of them have to equal. We know all three have to equal 180, right? So if I take off that 50-degree one, 180 minus 50 equals how much? 130 degrees. And I split that in half amongst angle X and Z. What's 130 degrees divided by 2? 65 degrees. So the measure of angle X is 65 degrees, and the measure of angle Z, love my handwriting today, equals 65 degrees. How could you check it? Right, add 65, 65, and 50, and they should equal 180. Good job. Good job. Okay, draw this lovely picture. I drew it, you can draw it. I'm still looking for my little clip.
I'm not looking
I probably cheated drawing that one.
that don't work.
Found it. I'm sticking it in my computer so I don't lose it again. Yeah, there's a right angle down there. And there's some crazy looking tick marks. I'm gonna go back to red because you can see it better.
So if X is the first even number, X plus 2 is the second.
Oh, we don't want much. Promise.
I think I know how to solve.
You think you do? All right, well, just finish drawing it. Let everybody else finish drawing. We can solve this easy. It's pretty obvious. It's obvious.
It is.
Makes me wonder if we as next genius.
I'm feeling smart today.
He's feeling his smartness today.
So X plus 2 equals 54. X plus 2 equals 54.
How many triangles are in this picture? Just 2, right? Because the whole shape together is a quadrilateral. It's not a triangle, right? All right. So, yeah, just 2, but they are sharing one side. Okay. Got to find X, which should be pretty easy, and then we got to find Y. So, look at this bigger triangle right here. What do you notice about it? All the sides are congruent because they have the same amount of tick marks, right? So that one is an equilateral triangle, and we just talked about an equilateral triangle is also what? Equiangular. So that means all of those measures are what? So X is what? 60 degrees. So I'm going to plug that in, and I'm also going to plug it in for all of those angles. That just helps me, right? Now, what does this little box mean?
Now together those are a right angle. So what is this one?
30 degrees. So, why? What is this? What kind of triangle is this? Isosceles. Two sides are congruent, right? So if this one's 30 degrees, is y 30 degrees? Not y, it's a vertex angle. So this top one is 30 degrees. Do y'all agree with that? So how do I get y? 180 minus, you combine those and you get 60. So y equals how much? 120 degrees. Now, I'll just tell you, your practice is going to be a little bit more complicated than that because they are going to use like expressions like x plus 5 and blah, 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 blah. But I'm going to give them to you in just a second and we're going to work on them and y'all can help each other and help me and whatever else.
So we get done with that, we ain't got nowhere to go.
Okay. All right. This is going to lead us into next week. This is not on your practice, but I want to go ahead and talk about it. This is kind of like an intro to next week. So go ahead and copy this down. Copy it down. We're going to talk about congruence for just a second.
You know, stay on the same paper.
Yeah, keep it on the same paper.
Now, if you have to see the visual, I know I highlight, if you have to see the visual, I have seen students that use circles and boxes and even triangles if there's more than 3 terms in certain cases. Okay? Do that. You can also use underlining. I used to do that, so I would underline this once, and then I would underline this twice. Does that make sense? Okay, do something if you need to visualize. So we said that this is 3x plus 6 equals 57. Now what? Subtract 6 from both sides. So 3x equals 51. Divide by 3. X equals 7. I used to know the first and second one. Okay. First. Now, again, what you're doing, you found x to be 17. You're taking 17 and you're going back over here and you're plugging it in. So 17 is the first. 17 plus 2 is 19, which is the second. 17 plus 4 is the third. 17 plus 4 is the third. So that's how we get 21. Does that make sense? Okay. Look at number 20.
Let me know if you can't read something.
Sum of 3 consecutive numbers.
College killed my handwriting. I used to have really good handwriting. College killed it. Taking notes at the speed of light.
So we don't have
Professors literally sat up on their desk on the front of the room and just started talking for an hour, and then class was over, and you had to catch everything they said.
So instead my handwriting's gonna get worse.
There's no luck for
It can't get no
you.
worse.
There's no luck for you.
So again, even in odd, it's when you do plus 2 plus 4 so consecutive plus 1 plus 2. Or you just want plus 2 is the third.
We didn't have smartphones back then.
So it says.
My phone didn't even have a camera back then.
My brother got some.
I started college about the time y'all were born, so let's just think about that. That's how old I am.
My brother got this thing. I don't know what it was called, but like everything that they say, he like copies and pastes onto a document, so he don't have to take that. So I think I might look it up.
Yeah, text, speech to text thing. Yeah.
And then,
All right.
it's a slideshow, like word for word.
But it doesn't organize it. You have to go back and organize it. All right. So let's just talk about congruence for a second, just to get us ready for next week. Now, objects are congruent if they have exactly the same size and the same shape. So we kind of talked about this in transformations a little bit. Think way back to Unit 2. All right? When we had reflections, rotations, and not dilations, translations, then we produced congruent figures, right? They kept the same size, they kept the same shape. We call those a rigid motion. All right? So congruents have the same size and same shape. If two congruent figures, all parts of one figure are congruent to the corresponding parts of the other figure. When I say corresponding parts, we're talking about sides and angles. All right? So, here's something cool. It says identify all pairs. Y'all write this down. All you have to write down is this statement right here. This congruent statement. Triangle JKL is congruent to triangle TSR. So it's telling me two triangles are congruent, and they want us to identify all the corresponding congruent parts. So all the sides and all the angles that are congruent to each other. Do I have pictures of these? No. Do I know their angle measures? No. Do I know the length of their shots? So how are we going to do that? I ain't drawing anything. I'm not drawing. I rebel. I'm not drawing. All right. So here's how you do it. All right. The way that we identify corresponding parts of congruent triangles or any congruent figures is in the name. How we name them matters. The order of their name matters. Okay? Put your pencil down right here and watch me. Watch me. Watch me. Go ahead. You see how J is the first letter over here? So angle J in this triangle matches with or corresponds with angle T in this triangle. And the middle with the middle and the last with the last. Okay? So the order is going to matter. So angle J is going to be congruent to angle T. And angle K is going to be congruent to angle, what's in that K spot? S. And then angle L is going to be congruent to angle R. First goes with first, middle with middle, last with last. So those are all of my corresponding angles that are congruent to each other. Now we also have sides of a triangle, right? Right? And sides are segments. Right? Right? Now for segments we need two letters. Right? JK is going to go with TS. And then you slide over. KL is going to go with SR. And then you split the middle. JL is going to go with TR. So how we name these triangles is going to matter. So I'm going to write that. Segment JK is congruent to segment TS. And then KL is congruent to segment SR. And then you split the middle. JL is congruent to TR. So without even seeing the triangles, without knowing a single measure, I know what all parts are congruent to each other just from the names. Just from the names. So we're going to stop right there for the notes for today. We're going to stop there. So that will kind of help us get ready for next week. And you're ready to do your practice. And I'm going to pass this out and we're going to talk over it for a second, but I'm going to stop the video right now.